Hello everyone, and welcome back to another Mathematics for GIS tutorial video. And in this video, I want to just go through how you can recognize the equation for an ellipse if it's not written directly in the standard form. And how you can tell, one, if it is an ellipse at all, and two, if it's centered at the origin or not. And it's really kind of quite easy to just gut check yourself as to whether or not it's an ellipse. Now, I'm not talking about the algebraic manipulation to convert them into the standard equation, but just a way to see that, hey, this could might most likely be an ellipse, or this won't be an ellipse, or if this is an ellipse, it's going to be not centered at the origin. So I'm going to go through this with three different equations to sort of walk you through how I can tell within less than 30 seconds if this is going to be an ellipse or not, and if it is going to be an ellipse, or if it could be an ellipse, if it's going to be centered at the origin or not. And it has to do with some very basic things. So the first question is this equation, right? This is 5x plus 3y squared equal 45 an ellipse? And I'm going to say no. Now, you might be asking yourself, well, how was I able to do that in the time it took me to read the question? And the reason I can do that is because in order for any equation to be an ellipse, right? Any ellipse must have both x and y raised to the second, actually let's write that out, raised to the second power and no higher. So if you see an equation that has an x and a y, and one of them does not have a second power, it's not an ellipse. If you see an equation that has an x and a y, and one of them is raised to the third power, then it is not an ellipse. Right? At a minimum, an ellipse has to have both x and y raised to the power of 2. Okay? So we know by reading this equation, the x is not squared, so this cannot be an ellipse. So let's do this one. Is the equation 4x squared plus 9y squared equals 36, is this an ellipse? Right? And so without doing the algebra, I'm going to say maybe. I'm going to say maybe. And I say maybe because I look and I see we have x squared and we have y squared. So this tells me maybe. But I can go a step further and I can say if it is, it will be centered at the origin. And in fact, this will almost always be an ellipse. Right? As long as you have an x squared and a y squared and no other variables or anything, it will be an ellipse. And it will be centered at the origin. And the reason I know this is if you only have x squared and y squared, then it will be centered at the origin. Right? We only have x squared, we only have y squared. We know this is going to be centered at the origin. Right? So what about this? Is this equation an ellipse? And the answer to this is also yes, right? Because we have an x squared, we have a y squared, right? And we don't have anything higher than squared, so we know it's an ellipse. We have an x and a y squared, so we know it's an ellipse, right? We've met the definition of it must have both x squared and y squared raised to the second power, and no higher, right? So the highest term in both is squared, so we know this is going to be an ellipse. And we also know that it will not, right? It will not be centered at the origin. And the reason that I know that it's not going to be centered at the origin is because we have this stuff here, right? We have an 8x, we have a 32y, right? When you have, if you have x or y raised to the first power, then it will not be centered at the origin. Right, and this, I'm not going to go through the math, but the reason that this is true has to do with when you factor a polynomial, right? When you use the FOIL method, right? You end up with, if it's not centered at the origin, right? If you have an h and or a k, right? When you do that FOIL method to factor your polynomial, you'll end up with some extra stuff, right? This 8x and this 32y. These two here indicate that it's not going to be centered at the origin. Right here we don't have that, so it is centered at the origin. And here, because this isn't squared, we know this is not an ellipse. Hopefully that made sense. We're going to go through some examples converting between standard equations and random equations. So hopefully it'll make more sense when you see some examples. But again, just a quick video showing you how I know if it's going to be an ellipse, if it's going to be centered at the origin, or if it's not. So hopefully this made sense. If you have any questions, please go back and rewatch the parts you're confused about. And as always, please reach out. Thank you.